GM everyone, welcome to a brand new episode of Protocol Explorer. Today I have Nenad with me. Nenad, can you give a quick introduction to yourself, what you do, and what we're going to be talking about today?
Yeah, hi Rahat, GM. So my name is Nenad. I'm a Devrel lead at Tenderly. And just briefly, Tenderly is the company that's building developer infrastructure, developer tooling, monitoring systems, Node RPC, so everything that Web3 developers need to successfully build dApps. And today I would like to talk about the latest addition to our stack, and that's in the area of development infrastructure. I won't explain too much now because we'll see it in action
Nice.
pretty soon.
So my overall experience with Tenderly has been kind of like using the simulation side of things, right? If I
Mhm.
wanted to like debug a specific transaction, some screw up I did with my smart contract, that's what I would use
Mhm.
it for, right? So where would you say like Tenderly's kind of like evolved kind of like more beyond, there's definitely more stuff to do beyond that, right? I guess like
Yeah.
that's my
Mhm.
that's where I'm most familiar with Tenderly. Yeah.
Yeah, definitely. So I mean, you basically touched upon the main areas of Tenderly, but I like to say that we have like the three pillars. That's development and staging infrastructures and infrastructure and tools. That's virtual testnets. That's the debugger. That's all the coding, call traces and stuff like that. So exactly for contract screw ups or for bad transaction arguments or just to figure out the assets that are exchanged and stuff like that. So that's the development, the staging infra section. Then there's the security and monitoring section. So and in there's like I like to say also two categories. Like there's proactive security, that's simulations. So you simulate the transactions before it gets signed. So you see what happens to the assets. So check yourself before you wreck yourself, sort of thing.
Yeah.
In that sense, it's proactive. There's also reactive security, that's alerting. So you can set up very, very robust alert and complex alert rules. Let's say I'm interested when an event parameter is greater than a particular value and the transaction value is higher than, and the contract and the sender is in a particular list or something like that. So when after the fact, you will get alerted that something fishy might be going on, or something fishy has started, or something good. why bad only? And the last bit of that monitoring side is Web3 actions. So it's like serverless backend for smart contracts, that where you can write a little bit of JavaScript that runs when something happens, and in that way you can like bridge Web2 and Web3, but have it contained within your Tenderly project. And the last segment would be the RPC node. And yes, it's an Ethereum node, but it's got highly accurate gas estimates. It's also enriched with Tenderly's traced coding, with Tenderly's simulations as well. So everything that you see on the dashboard, almost everything can be accessed through the node. So it's like an easy integration. And the last bit in there is that it's extensible, so you can actually write your own RPC methods. So that would be like if the shortest sort of overview of the tools that we have in that landscape.
Gotcha. So there's definitely quite a lot more than what I've
Yeah.
been playing around with. So now this is going to be a good learning experience for me as well, which is
Mhm.
what I really enjoy about doing these like streams and episodes. So that's awesome. From all of these different things, like I guess like what's been kind of like what do you feel like has been like a real game changer for devs? Like that has been like very helpful
Mhm.
for developers to like just build out different projects or like what do you feel is like one of the more useful things
Mhm.
for people to focus on?
Yeah, I mean, through time, the first very useful thing was the line by line, actually call by call debugger, where every single method argument is decoded and the gas is
Yeah.
profiled. So there's that. Then we had simulations where people use like the simulation UI, but also the simulation API and the simulation RPC. And I think virtual testnets that are the topic of today are the next, let's say, hopefully very useful thing for devs. And judging by the reactions of many teams that worked with us in the closed beta phase, and now when it's public, I think it will make development much easier and smoother and more sustainable.
Nice. Yeah, I remember when I first saw the announcement for like the I guess I wanted to, and you'll probably go into this shortly.
Mhm.
But like when I first saw it, I was like, "Oh, this is really cool." This is like my immediate thought was like, "This is very similar, kind of to like what Truffle Suite kind of like had before, but like on another level, I guess, with like some of like the local debugging and like the local explorer type
Mhm.
stuff." Is that kind of like a good way to like look at what you guys are trying to achieve too?
Mm, yeah, so I think the main let's say attribute of virtual testnets is that it is a shared piece of infrastructure. So if I create a virtual testnet, I can share the RPC with you. You're in my team, so you can actually see the block explorer for it.
Mhm.
You can manipulate states. So it's actually helping people in the team work closer together. Or if you have a dispersed team, like back and front end data, whatnot. In that case, even though those teams may be very very siloed, they had common infrastructure so
Right.
they can share updates to contracts more easily, so front end devs can integrate sooner, and then the data guys, they can do their stuff without being without interference with front end data and stuff like that. So it is more about common infrastructure for protocols and teams.
Gotcha. Okay, no, that helps to put it into like a more bigger perspective. Cool.
Yeah.
Nice. I think do you want to go a little bit further into the side of things here?
Yeah, sure. So yeah, I'll just yeah, let's share the screen, I guess. Let's jump
Yep.
right in. So we can take a do a little walkthrough together through this. So this is the Tenderly dashboard. It's in browser sort of thing, and everything I spoke about is here. So the Node RPC, the virtual testnets. This is data that's coming live from mainnet essentially, and some stuff that's here in development and again monitoring. So I think let's just jump right into testnets because that's what I want to talk about today, and we will see majority of these tools in there because it is integrated.
Mhm.
So let's just create one. So I can base my testnet off of any network that Tenderly supports, and that list is growing. It's more than 40 right now. So I'll just pick mainnet and just give it a name. And here I can actually give it a custom chain ID, which is a good idea to prevent transaction replay attacks, because the idea is you will send transactions to this testnet. So to be absolutely sure that they will not be replayed in case that by mistake you use an actual wallet, then you can add a little prefix. I like to add 7357. It's practically test and in decimal numbers, and just prefix it there. But if you're sure that you will not use a wallet that has actual that can do stuff, then you can keep the default. Now, testnets also come with a public explorer because you can share them to your team, but you can also share them externally. So if you have people testing something, you can give them access to the explorer of the testnet, and you can either give them full visibility into contracts, or just give them ABIs of signatures, or give them none of that, so they don't see your code. So you can imagine, like, if you're doing some sort of demoing and you don't want contract code to leak, then you can set this to none. And this one, I will just switch on. The last bit here is state sync. So what's really distinct about virtual testnets is that they continuously get updates from the mainnet they're forking. So let's say you have an Oracle on mainnet and your testnet is interacting with it. It will get the fresh value from that Oracle every single time you want to get the value. Or and stuff like that. This also applies to any contract, any liquidity pool, anything practically that's on chain. So these are the couple of things that we configured, whether or not we want state sync, whether or not we want a state explorer, a public explorer, and just the basic configuration. And I will hit create, and it's ready. So this is
basically just creating a fork of mainnet, right? Essentially.
Correct. But if I share this link with you, you could open this very explorer and just check out all the methods that check out all the calls that have happened in there.
Nice. I see that.
Yeah. So I created a network, and I probably want to play around with it. So the first thing I will do is I will add this network to a wallet. So we have a little button that will actually add it to MetaMask, and there we go. We're switching to, yeah. Let's just check in MetaMask what happened in there. Okay, fine. We are, where is it? Yeah, here. So it's the exact name that I entered. So MetaMask is now connected to this thing. So far, so good. Now, some useful things that you can do, and I think this is most important for most of us. So how do you fund your wallets? So to do anything, I practically need test ETH.
Right.
So what would your guess be?
You'd have some type of faucet, right?
We have some type of faucet, exactly. But so here it is, the faucet. So I can just enter this address and click fund, and there you go. I have 1,000 ETH. So faucet is weight free, and yeah,
it's a very generous faucet.
Yeah, exactly. Let's just it'll show up in MetaMask as well at some point. Yeah, there it is. Okay, so that's cool. But what's also cool is that I can mint ERC20 tokens. So practically any ERC20 token, anything that implements the standard, you can just paste the token address, the amount, and you can practically get assets out of thin air because they're virtual assets. So that's possible. so you can build up anything you need to test a particular scenario or do something like that. And interestingly, among the auditors, this is a very useful feature, because if you want to try out something that involves moving high volumes of native or ERC20 balance, well, then this is a pretty nice way to set it up and just try it out. All right, so that's when it comes to faucet. Now, when it comes to interacting with this thing, of course, we have the RPC that you can use, but also what we have is this sort of interface you can use to specify your transaction and just send it. So here there is this little send button. So if I press this one, and let's just take swap router. So this is like the Uniswap contract of the mainnet, and I want to find a little method. Yeah, so let's just pick a read method, a factory that will give it to us. But if you also go for a more complex method with parameters, then you get input fields to select all that. So let me just grab the factory address. So if I hit this, I instantly get a virtual transaction in there. So this is what I get. This is the output. This is the output as well. So in that way, I can interact with contracts that are deployed either on the testnet or deployed on the mainnet we forked from. So everything is fully available.
Cool. So if I wanted to like mess around with building something on top of Uniswap, now I could like directly interact with Uniswap as it was in the state when I forked the mainnet into my testnet.
Yeah, pretty much. Actually, since we kept the state sync on, that means you will interact with Uniswap as it is this very moment on mainnet.
Okay. Nice.
So yeah. So it'll be like you're talking to mainnet Uniswap, but anything you do as a state change it will be in the virtual testnet. You can think of it as a working copy, like back of the napkin calculation. We store it, but it's not touching the chain, the original chain.
Got it.
So there's that. Of course, you can disable that, and then you're fixed on at the forking point.
Got it. Nice.
So yeah, so there's that, and I guess this is probably useful when you want to build some sort of proof of concept or just try out a transaction scenario or anything like that. And next to sending the transactions, you also have the simulator. So if you don't want to do a mutation on the testnet, you can also simulate on the testnet. So here I can just take the swap router and yeah, let me just call this method. So this is just a simulation. This is like ephemeral sort of calculation. It's in here, but it is not embedded in the chain of the testnet. So if I go back here, you will not see factory v2. You will just see the one that we called previously. So
Got it.
So this is also like a scratchpad sort of thing with the simulations.
Nice.
All right, so this is pretty cool, but if we think what the next questions builders would have, that would be probably around RPCs, and you can see here that when you create a testnet, you get RPC. Actually, we're getting two. One of them is public, the other one is admin. So before we do anything, I would just like to touch upon what admin RPC is. And basically, that's the RPC that enables us to simulate things. It's the RPC that enables us to fund accounts. So basically, that's the RPC that's sort of enriched with methods that allow you to do stuff like that. So there's increased time, increased blocks, so you can simulate passage of time and mining of blocks on the virtual testnet. If calculations in smart contracts are dependent on the timestamp and the block number. Okay, there's send transaction, which are unsigned. That's also possible. And of course, there's the unlimited faucet that allows you to set balance, set ERC20 balance. And for example, this is the way that you would use it. For set balance, you would have to give an array of wallets and the value that those wallets get. So you could practically, fund 100 wallets in one go in less than a second. And I think that's for
Nice.
complex test scenarios. I think that's pretty awesome.
100%. Yeah.
Yeah, that also applies to ERC20 balances. And now there are two methods that go very low level, and that's set code. And this enables you to give it a contract address. It says 0x1 here. So you give it a contract address and you give it a bytecode. And from that point onward, that address will have that bytecode deployed for you. So that could be, I don't know, some sort of instrumented bytecode or just some sort of modification that you're doing to the bytecode of the existing contract, or you just want to deploy that way because it's fun. That's also doable. But yeah, this allows you to set the code to a particular address. And what's also there is, in the standard set of JSON RPC method has the get storage at. We also have the set storage at. So if you want to, avoid mocking and actually modify a contract and modify a particular slot, then you can do that. So you should give it like the contract address, the contract variables location within that contract's address space, right, and the value that you want to put in there. So this is practically assignment. Now the biggest issue is how to get this one, and that's that's something that that we need to solve, right?
Nice. Okay.
Yeah. So this is the RPC that you're actually getting. That you can integrate in your backend or any sort of utility script or front end, and and work with that. And I think for front-end builders in there, I think this is useful because you can just add balance to your
Right.
accounts that you're doing testing with. And this is exactly what we're going to see right now in the second show and part of this show and tell.
Yeah, I would say one of the most annoying parts sometimes with like front end development in Web3 is like, crap, now I have to go get like XYZ RC20 token, getting this, that, whatever. So this is incredibly useful for like testing different things. So this is really cool.
Yeah. All right. Let me switch over here. Now, one thing that I find this to be helpful with is actually CI. And this anyway, that shouldn't be there. So essentially what we do is, you have your backend, you have your front end, you have your Solidity code, and we'll come back to the front end building just in a second. But ideally, what happens is, okay, you got some contracts. There are some changes in there, and you push that to a Git repository. Ideally, what would be ideal is to have all those three components deployed and interconnected, so you can either do any sort of automation testing, or deploy it for staging, for team internal testing, or for any sort of demoing or anything like that. Or when it's early in the process of building it, you might just want to deploy your smart contracts and have them available for the front end, to the front end, and on the back end, so other teams can keep building on top of that. And let's just take a look at how that might work. So this is like the Ethereum mainnet, and you have a smart contract dev, and that smart contract dev can deploy their contracts on a virtual testnet. The other teams could either fork that testnet further, so you can fork the testnet as many times as you want, so you can do a whole tree of that. So imagine that when this push happens on GitHub, then a GitHub action starts that actually instantiates a new testnet, deploys those contracts over there, and then takes over the configuration to backend, whatever backend is, to the front end, probably next. And if there's a data team or something like that, delivers that configuration over there as well, and of course delivers it to any indexer.
So essentially, each of these teams can have like their own environment.
Yes, exactly. So each of these teams, completely separate working copy of those contracts that are deployed there. So like let's assume this is me, a front end dev. So when I try and test something, I will send completely hectic data in there. I will just click and do stupid things just to have my UI work. But if there's a data guy in the team, they will not be happy with the data person will not be happy with that junk that I made. Right. So from that perspective, having that sort of common code base, common contract base that is deployed and live that you can work with, but have it in a way isolated, I think that is what can help teams move faster.
Got it.
So this is what could happen, and the idea is that this GitHub action over here could take these components, take smart contracts, deploy them to testnet, and then connect the backend and the front end to the testnet. So these dotted lines that connect these components, that's the infrastructure, that's the staging and development infrastructure that could bring all these things together.
Gotcha. Makes sense.
Yeah, and especially if we're talking about Web 2, and everybody who's taking on Web 3, I think this idea of having a good CI system that helps you put things together faster without doing a big bang integration and run any sort of tests and do any sort of demoing or testing, I think this is something that might appeal to them as well, because that's what the, let's say, standard is there.
Yeah. Yeah, I'd say like before I saw this, I don't think there was a really good example of like really good or robust CI in Web3. So this is now very useful, I think, for a lot of different teams.
So I would like to see it in action. I would like to
Yeah.
stop with slides and talking and just move over to code.
Cool.
So let's jump in there. What I have here is actually before I start, is the font big enough
If we could bump it up a
to
little
be
bit.
viewed? Yeah, let me just. Yeah, should I go with Zoom? Yeah.
Yeah, that's good. I think.
Better? Better.
Much
Awesome.
better.
All right. Okay. So what I have in here is scaffolding 2. So it's like the scaffolding framework that we have, and usually it's Hardhead and Next.js. So here's where your contracts lie. Here's where your UI lies. What I added here is a little tenderly folder that contains just a couple of scripts that help bind everything together. And I must say, if you go to GitHub and find it, there are certain modifications to the original code base of the front end, because something had to be tweaked a little bit in order for this thing to work. And anyhow, the idea is, let's imagine that I'm a smart contract developer. I did something in here. Actually, I did nothing. This is just the original contract that you get with Hardhead, I think, or with Scaffold ETH. Doesn't matter. So let's say that I completed something on the smart contract side, and then I want to create a new environment. So let's come back to this image. So I want to create this new testnet, and I didn't deploy anything yet, so I just want to take it down. What I would do is I would run, okay, I would run this little script, stage new, because it's sort of like staging and environments. And this would be the name of this environment that I'm creating. So it could be, I could call it just live 1. Hopefully I didn't take this one. And then I need to give it a list of chains that I'm interested in. So if I don't add any, then you will get the list of all the chains that Tenderly supports at the given moment. So I'll just take, let's say, mainnet and base, and I will run it again. So this will give me 2 virtual testnets for these 2 chains. And there you go. We got two RPCs. If just double check everything, I will go back to my browser somewhere. Here it is. And hopefully it's here. Yeah, we got it. So it's live mainnet and live base. So that command over there worked. I have my 2 chains that I'm using within this live environment. So if I go in here, you can see that it's just loading, even though it's empty. It's got a pretty ugly name because the name actually includes the hash of the current commit in my repository, something just to tell them apart.
Gotcha.
Yeah. So this is ready. And now the next step would be to actually point Hardhead to deploy contracts on the testnet. And there's a script that I created for that. But just before I do that, there's also virtual testnet support Foundry, including verification. So there is a guide about that for all those for all the people who use Foundry. So here you can find a little guide that explains how to deploy the contract. Of course, it's just Forge create, but also all the stuff you need to do to verify the contracts along the way. So to enable debugging, essentially. And this should load. Let's see what happened. Okay, segue over. Let's come back to this. So what we need to do is to connect Hardhead to talk to this virtual testnet. And actually before that, since I can have a lot of environments, and here I have a lot, so I have a bunch of locals, I have origin, blah blah blah, a lot of things. I want to switch over to this one, live one. So I will just run a command stage activate, and oops, no, it's live. So this takes this configuration, and now I can actually connect Hardhit and Next.js with it. So I can just say npm run connect Hardhit. So this one will get passed there, and yeah, it's already done. So now I can switch over to my Hardhit bit, and that's one of these terminals. This is next. This is Hardhit. I'll kill this one. So I can switch to this one, and I can just say, okay, deploy any contract to the virtual mainnet. That's the mainnet version that we created. Oh, yeah. So this error, I wanted to avoid it, but I didn't. What essentially happens
the perils
if
of live coding.
Yeah, exactly. What happens in here, since I had a previous deployment, Scaffold ETH or Hardhead actually, just had that deployment persisted here. And now I have a brand new chain and it cannot find this contract on this address. So what I need to do is actually remove this folder and everything will be fine. I can run it again. Let me just clear this one. Yeah. So there we go. It also has some manipulation of balances, and you can see that it says, okay, the contract is there. It's also verified on the virtual testnet. So if I just click this link, hopefully I get everything loaded. Oops, this is not right. Let me switch over. There we go. So this is our live mainnet, and you can see that there are some balances that are set. This is the contract deployment call, and there's a mining that happened. And just to double check, I can open the contracts, and in here I can see that there's something called your contract. That was the name of the original one that we just saw. So it is actually this one, building unstoppable apps that we have in that repository over there. So contract deployment successful. And now at this point, I can take this RPC link and I can hand it over to anybody who is within my team so they can work on it. And also I can open this public explorer if I want to share a public explorer to the world. We'll check out Public Explorer one more time, but now I want to switch over and move into the shoes of the front-end developer. So going back to WebStorm, and I want to do something on my UI. So I'm going to do something in Next. To do that, I would have to, point Next to that virtual testnet that we created, and the command is pretty simple. Just stage connect Next.js. Now, what this thing does, it sort of creates configuration that is, again, in here. And it contains the networks that were created for this stage, this environment, actually. So this is all exported somewhere in Scaffold ETH config. So everything gets connected to this virtual testnet. So after connecting Next.js, I can just spin up the server here, and yeah, I open it up, and here we go. This stay there. I want a fresh start, and okay, it connected again. What I wanted to point out, one cool thing about testnets is that you don't need to, when developing at least, you don't necessarily need to use actual wallets. Scaffold ETH comes with Burn a wallet. So you could actually use that, and you could avoid all those steps of approving, which is, I think, something that makes it super fast for front end devs to move through building UIs. So I'll just select that one. So this thing actually generated a new account for me. That's what burner wallets do. They don't persist addresses. They just create new ones every single time. And of course, there's a faucet. So if I click this, I should have gotten 1,000 ETH, but this thing doesn't reload as fast. So it doesn't reload at all, I guess. Okay, now we're in the demo mode. But you can see actually that there is set balance that happened just now.
Mhm.
So it's 100 ETH, not 1,000. So this is what happened because I clicked this faucet thing here. So if I click a couple more times, it'll be there. But for some reason, this did not get updated. But okay, let's just keep going with this. So in Scaffold ETH, there's also this debug contract things. Oh, something is off in here. Yeah, I guess the contract was not, the configuration didn't really go that in there. So I cannot interact with with this UI at this point, which is a little unfortunate. So it says here that the contract address is EA something something. And let me just check over here. So it says your contract in there. Yeah, it does say that it is EA66 for some reason. So I mean, it looks like, yeah, this is the contract, but something here is off. So yeah, we're not getting the update of the actual balance. We're also not getting this, but probably something in the configuration went wrong. So this isn't coming together here. But I think this proves this shows like the main route and the main point that it is relatively easy to integrate it
Definitely.
with yeah, just sprinkling around the RPC links to the virtual testnet, to whatever you're using, whatever library, to component library or client interaction library. So practically whatever you use should be easy to connect in there. And again, we have everything visible in here now. It sucks that I can't really show this part where I interact with the contracts right now, and I would like to debug it. But you can see that the stuff is coming through.
Gotcha.
Yeah.
Nice,
So
nice.
there's that. I would like to, so since we cannot see the debugger and everything else in there, I would like to just take a couple of minutes to check out debugging from on a real mainnet, just to give you the feel. But before that, is there anything that piqued your attention or something
No,
that?
so far this seems awesome. Like it's a pretty seamless experience. I really like kind of like like obviously you can go on test networks, do this and that, but like you don't always get like the proper data. Like when I remember when I was like building like I was trying to build a demo using like account abstraction on top of Uniswap, but like using Uniswap pools on testnet is like a nightmare. So like
Yeah.
having something like this is just super dope. Like you can just build your own environment, actually interact with like Uniswap as it is on mainnet. So like I had to do those demos on mainnet and spend actual money. So this if I had this would have been great.
Yeah. So this takes you to a different way of doing that kind of stuff and interacting with real stuff without really interacting it with it. Virtually interacting. Yeah. That's why it's there. Yeah. So now that we're mentioning the real networks and the Uniswap, I'll hop out of the VNet. So this is the list of my virtual testnets, and let's see how we can actually do something with Uniswap from mainnet. So in order to do that, I would have to first go into this contract section here. So I would need to add the contract I'm interested in, and this is swap router. Maybe we can play around with that one. And then when you go into transactions, it will list all the transactions happening to those contracts that were added in that list. So this is practically your filter for all the transactions that you can see here. And let's check out a successful one. I'll just open this one. So there's plenty of information that you can see. You can see token transfers. So this is ERC20 token transfers with the actual price in dollars, but you can also see the native token transfer, so ETH or whatever the native token of the chain is. So that's the first useful thing. Now, if you're on the building side of things and you want to check out the code and that kind of stuff, then you can just glance through decoded inputs of the function and the decoded outputs. So this is all fully decoded. And right now we're relying on either the contract being verified on Etherscan, BlockScout, and places like those. Or you would have to do verification within Tenderly. So for example, when you deploy our contracts or later on, you can use our verification API and just have it verified in there. So there's that. And I think it provides real depth of information. And here you can see a very, very decoded code call trace. If this is too much, you can just opt out from the full trace, so you get all the calls and stuff like that. What's also in there is event logs. So these blue ones, they're showing where the logs were emitted within the call trace. And there's also storage access, so you can actually see every single slot, so for stores, of course, the old value and the new value. For reads, the value that was read. So there's that with this, let's see, fully decoded call trace. Now, other interesting things that you can learn about this transaction is, of course, the list of all events emitted at one place. So the collection of all events emitted throughout its execution. You can also see the state changes at the very end. So you can see that this variable square root of price changed from this value to this value. It looks like it dropped a little, or yeah, big numbers I can't really compare now. There's also mappings that are decoded. So even if you have a complex mapping, like mapping and then address to a map and stuff like that, that could also be decoded. So you can just find your way through that. And the gas profiler that we mentioned. So it's a little flame chart you can use to jump through these calls, and it can even serve as a visual tool to just understand how that call trace is actually structured, and just in a different way, because you can zoom into a part and then zoom out and do stuff like that. And of course, you can view this in the debugger. So if I click this button, I'm going straight to the line where this function call happened. And in here, I can see, everything decoded: sender, receiver, including their balances, the inputs decoded, the actual gas used and the gas left, gas used by this function, and gas left from the gas that was initially submitted with the transaction. So there's that. And as I said, it's call by call debugger. So it's not line by line, unfortunately, not yet. But this gives you like a way to go through everything that's happening in there.
Gotcha.
Yeah.
Nice.
So this is
a cool overview of things.
Yeah. This is pretty much similar experience that you would get in the virtual testnet as well. So everything that you see here works almost identically in there. So that's what comes with the virtual testnet.
Nice, nice. Cool. I had a question in my head
Hmm.
actually. So when we were talking earlier about like my situation of like, wanting to do something on top of a Uniswap or whatever.
Hmm.
Um, in that specific instance, like I had not only like the on-chain aspects, which I guess like you guys fork here, but there are like off-chain components. It's like different things, right?
Hmm.
So
Hmm.
let's say with like something like count abstraction, there's some off-chain components with stuff like paymasters and bundlers. Is there a way for like these infra providers to like maybe even deploy their some type of infra to like support like stuff like account abstraction in any way?
Mm, yeah. So all the off-chain infra, it would have to be deployed um, and connected to the VNet. So in the same way, we just have to, if I want to stage a dapp front end, I would have to deploy that front end
Right.
connected to the VNet. So in the same way, any off-chain piece, it would have to be deployed as a separate version on the virtual testnet. Or um, what could also work is if that off-chain component could be pluggable. So testnet could be plug and play. If I can configure the RPC it talks to, well, in that case, that's possible. And a practical example is something that I'm playing around with in the past few days. So I'm really experimenting with staging different components. So there's, of course, you can run a data indexer, for example, on testnet, but uh, if there's a hosted solution for it, well, you can really use it with the virtual testnet because majority of providers have a locked list of networks they support for very, very clear reasons. So in that case, what I'm playing with now is just figuring out what are the ins and outs of deploying such a component with the virtual testnet and figuring out how to go, where to go from there. But for now, it's on the devs to stage those components
Got it. Cool.
where
No, that
possible.
makes a lot of sense.
Yeah,
Awesome. Yeah, that covers the questions I had so far.
yeah. All right. Do we have perhaps any other questions or something that I could
Nothing that's
share?
come up just
Yeah.
yet. No. Maybe I guess like overall, um, for devs who want to get started building on this,
Mhm.
like how does like pricing tiers kind of like work? Is there like a hobby kind of like tier for devs to come in and try it out before coming into like working
Mhm.
as a team here?
Yeah. So we do have a free plan that's pretty generous, and like a lot of these things you can play around with, of course. Um, when it comes to, like, I don't know, if you want to index more than uh, more blocks, like thousands of blocks, well, that free plan will pan out. And
Right.
in that case, there's a developer plan. Uh, Actually, in that case, there's 2 week free trial, so you can actually play around with it with fairly high um, amount of what we call tenderly units. So that's just measuring the resources and the activities, the actions that you do. So you can do a lot in there, and after that, you have a developer plan that individual devs can actually use,
Gotcha.
and this gives you, yeah, the tenderly units and appropriate rate limits that we don't expect individual devs to eat too fast.
Gotcha. Cool. What's the best way for devs to reach out to you for questions or getting started on different things here?
Mhm. Yeah, so this is my Twitter handle, so you can do that. You can also on the docs you have a link at the very top. It's scheduling office hours. This week and next week are actually taken. Let's say next week there's ECC, so I'll be there. It will not be possible, but a week after, of course. And also on our website and docs and dashboard itself, there's an intercom button. We have an amazing support team, support engineers who are helping out builders to overcome issues and fix bugs. So those are the three major ways you can reach out.
Nice. Awesome, man. Thank you so much for doing this. Is there anything else that you want to wrap up with? Anything else that you want to make sure folks know?
Yeah, well, I didn't really think about this, but I would say stage everything.
Yeah,
Yeah, that's what I would say.
that's
And
definitely
of
what I
course,
got from this.
if there are folks who are interested in this, please reach out, because I'm really in this topic right now and would like to connect with people who are curious about it as well.
Awesome. Amazing. Thank you so much for being on this episode with us. I learned quite a lot. It was very interesting going through just like all the different offerings that you guys have. Even in just this one service, it's like crazy to see. So it's really cool. Thank you again. For folks tuning in, if you want to continue to be updated on like the latest episodes that are coming out, definitely join the Telegram group. That's available. Will be available in the description as well as in the comments below. So check that out for future episodes. We will not have an episode next week because yes, it is ECC, so I'll also be there. But we'll resume Protocol Explorer the week after, so look out for announcements for that too. All right. Thank you all for tuning in, and thank you so much, Nenad, for teaching us all about Tenderly today.
Yeah, thank you for having me. It was a pleasure.